welcome to start the presentation.
Perfect. Thank you so much, Anna. Thanks for the invitation, and thank you all for coming. And I guess just by way of introduction, I should say I have AI in my title now, and this is a very, very, very recent thing. So up until a couple of, well, I guess up until about 2 months ago, I was working more in a kind of a typical research administration and knowledge realization focused role, but kind of pivoted in the spirit of the times to experiment and learn more about the opportunities to embed AI in more institutional and administrative workflows. So my chat today, just by way of a little bit of overhead, is I want to talk about a few terms that I want to use throughout the next hour and make sure kind of hopefully we all have the same things in our heads when I use those terms. So I'll do a little bit of some definitions. And then the bulk of this presentation will be looking at two case studies, a tool called Automated Grant Feedback and another project called Research Mesh. And then I'd like to conclude by, I guess, some reflections and provocations and more just some ideas about how this technology is impacting what we do in administration and what the kind of labor and work ramifications of that might be down the road. Have more questions than answers myself, and hopefully that can generate some comments and discussions. So by way of defining a few terms to get started, I'll refer to large language models or LLMs, and we probably, by now it's 2025 and we probably have, some idea in our head as to what these things are, because things like ChatGPT and whatnot are very, very popular. But I think it's worth actually pausing for a moment and just getting on the same page as to what a large language model actually is. And we often talk about these things as being, next token prediction tools or, platforms that predict the next word, which they very much are. So if I said, hey, the dog opened its something and barked, there is a word that goes there that has a probably higher probability of every other word. If a dog opened its Renaissance and barked, wouldn't make sense. The dog opened the pizza and barked. Doesn't make sense, but that's actually closer because pizzas go in mouths. And so the dog opened its mouth and barked is, probably a fairly good prediction as to what the word is that should go in that blank spot. And we had tools that could do this before we had ChatGPT. I know when you're texting, on your phone and you see those little words pop up that are predicting, what words you might want to say next. Those pre-existed large language models because it's fairly straightforward in a sense to predict a next word in the kind of a mathematical matrix. But the interesting thing about the GPT part about ChatGPT is this idea of pre-training a whole neural net. And so if I say to you, well, what is a dog? You describe a dog in a bunch of words, then those words refer to concepts. And the definition of a dog is a bunch of words that refer to a bunch of concepts that together then describe what a dog is. When you pre-train a neural net, you end up doing something similar where the set of words that represent those concepts become affiliated with each other within that training, within that neural net. And so that model can do something more like what a human brain does when we think about a dog than the just word prediction. So for example, right, if I say to ChatGPT, write me a 4-line of a rhyming poem about dogs barking, you can obviously do that. And so more than just, understanding some concepts like I wanted 4 lines and the idea of rhyming and the idea of adversarius, each line starting with a new letter in the alphabet. You think about it's not just dogs, and it's not just dogs' relationships to passing cars or what we might call dogs, but it's all those concepts together that allow these tools to do what they do. And so when you take some graduate student and they say, well, okay, based on my course reading and my syllabus and the posts in this discussion so far, what perspectives or angles to this online forum, to this conversation could I use that demonstrate my deep comprehension of this week's learning objectives? Write me a 2-paragraph response. A model will do that effectively to some extent because it has that deep intersecting uh, understanding, not of not of concepts themselves, but of how those words that to humans reflect concepts relate to each other. So Sam Altman, the big cheese at OpenAI, who may or may not be the Antichrist, and that's another discussion, said an LLM is a calculator for words. And I think if we're going to define an LLM, that's a really interesting question to actually ask. Is that true? Is an LLM just a calculator for words? And my argument is that that is absolutely yes, that's absolutely true, and absolutely no, it's not true at the same time. So it's absolutely a word calculator in the sense that an LLM is 100% algebra on steroids, right? To do that kind of triangulation of words to represent concepts in that way, that was a whole lot of math. Absolutely. So do you need a calculator to do a whole lot of math? Yes, you do. But it's absolutely not a calculator in the sense that actual calculators do not infer, estimate, confabulate, or persuade. Very often we hear, the term hallucinate, like the LLM hallucinates, which I think is kind of a very unfortunate term because everything an LLM generates is actually an hallucination in a sense. It's an estimation and confabulation based upon statistical probabilities. And so to say that some of the things that come out of an LLM are hallucinations and some of them are truth is a non sequitur in the sense of what an LLM actually is. It is all a confabulation, and that is exactly what comes out of it. Confabulations come out of it that don't reflect things that we understand to be true in the real world. So we call those confabulations hallucinations, but that's just us using language. As far as the calculator is concerned, it's doing what it's supposed to be doing all the way through. So you can build 3 things with one of these fancy word calculators, maybe more things, but these are the 3 things we know about right now. You can build chatbots and agents, and you can incorporate them into automations. And so for chatbots, obviously, I'm not going to spend a lot of time talking about chatbots today because we very much have a sense of what those are. Agents are a big thing that a lot of people are working on right now, which is the dream of being able to ask your Alexa or Siri to do a complex series of things for you, like here is my kid's soccer schedule, put these things in my calendar, and email my partner to tell them that the soccer schedule or the football schedule is in the calendar. This is an international group, so I shouldn't say soccer, I should say football. But automation would be the other thing where you then use some of the intelligence, quote unquote, that you can access through an LLM within an existing automation. And this is the area that I'm going to really focus on here. But a few more terms before I get there. I'm going to talk about application programming interfaces, or APIs. And this is the little bit of code that one computer program sends to another computer program when it needs that computer program to return it something. So this, this is an API call of some application talking to the Anthropic's Claude model, asking what is the capital of France. And if you're not a coder, you don't have to be too scared. This is actually not as terrifying as it looks. This is the endpoint. So this is where it's going to go talk to the Anthropic bot. This is like the little code that says I've paid for a enterprise license. I'm able to do this. And then you can see down in this JSON payload, what is the capital of France is the question. So when you're using chatbot, you are using an application that is sending messages back and forth to a model using an API. So your application, your chatbot application, is just that. It's an application that serves as the interface between this code and you and the questions or the queries that you have for the model. So when we talk about enterprise applications, I could combine all these terms here. We're talking about using automation to leverage large language model APIs within institutional workflows. So I'm going to give two examples of connecting APIs with automation in the context of research administration at the kind of scale of a enterprise deployment. And my first case study is, as I mentioned earlier, looking at automated grant feedback. So the question driving this project was a question not new to any of us in research administration, which is how can you help a researcher identify as many potential perceived weaknesses as possible in a grant application? And of course, we have been asking this question in research administration long before AI came onto the scene. But AI came onto the scene, and our question was, well, can we use AI to help us do this more effectively? And so what we did was to take the criticisms and the critiques and the comments from previous applications, both failed and successful, but especially failed applications, and then built a data set using that as our training data to help an LLM understand, well, here are the kind of things that in the real world, real reviewers critique about applications. And so our pitch to potential users of this tool basically is, well, would it be helpful to you as a faculty member, as a researcher, as in this case a grant applicant, to compare your application against a database of criticisms that have been made of past grants, of past applications? And this is what the tool looks like, which is it looks like a Microsoft form because it fronts as a Microsoft form. Very fancy user interface. And you can see it's very straightforward. Someone uploads their draft application. There's some kind of options for the kind of analysis they can receive as captured in this screenshot. And worth pointing out is that we ask faculty members or whoever's using it to acknowledge the entire data pipeline. So this tool does use some third-party platforms. Obviously, data goes off-site from the university's Microsoft tenant, and so that document, that document with the URL there, walks people through exactly where the data goes, what its retention policy is, how quickly like log data is deleted, all grounding back to the license agreements signed with the third parties who are providing those services. The person has to be the principal investigator on the application. That is, they have to both declare this, and the model does internal checks on this because here in Canada, and I assume in many other places, it is very forbidden to use AI to assist in the review of grants, and we don't want this tool to be leveraged potentially in that way. And so to submit this form, the user has to be logged into our Microsoft tenant. So we verify that user against the application as a second check. They have to agree that everyone involved in the research itself, in terms of developing the application, also understands what the data confidentiality and privacy ramifications are. And everyone needs to click on this is an AI thing that we're working on, and who knows what it's going to actually do. So there are the things that the applicant has to say. Everything in this workflow uses Microsoft Power Automate. So this is a no-code, low-code platform, which you might even have access to if your institution is on the Microsoft 365, within the Microsoft 365 ecosystem. So internally, the user submits that form, and it goes off, and it triggers the automation that does everything that comes subsequently. So we run this application through a loop based on this historical reviewer assessments. So, for example, the application must state what gaps in current knowledge will be addressed. So does this application do this? Yes or no? How well does it do this? Every stated hypothesis must be accompanied by clear and explicit rationales. Does it do this? Does it not? How does it do? All topics, areas, and themes proposed in the application must be addressed in the literature review. Does it do this? Check, check, check. So it's about 120 benchmarks like that. And those benchmarks, like I had mentioned before, extrapolated from previous reviewer comments on past applications. So 3 different LLM models internally run that assessment. So the workflow looks something like this. There's different sections where there are different kinds of analyses. So let's say we're looking at study design questions. Then there's an OpenAI, Anthropic, and Claude, and Anthropic and a Google model that then do the assessment. Then within each section, there's a reviewer model that tries to consolidate that output in a way such that it might be more helpful for the person uh, having their application reviewed. And then the final output, the reviewer, the applicant gets a kind of section by section analysis. And this is meant to, in some ways, kind of replicate like an SO or scientific officer report, and more of a high level summary, because it can generate a lot of, you have 3 LLM models asking 120 analysis questions of an application. It generates a lot of data. So there's a signal and noise challenge with all that. But then the applicant gets this overview of potential issues, as well as the complete just data dump of how the model itself kind of generated all that output. So on a typical grant that would be run through this, it generates upwards of 50 pages of output once it's PDF'd and sent back. That I would say is like a current limitation of the model, is again to the signal to noise challenge. Like that is, oh, nobody feels like an extra 50 pages to read in their lives about anything. But That's why we've tried to put that kind of first layer on, that higher level summary. But this is an ongoing challenge, and in the subsequent version of this tool, something we're working on addressing. And this is just kind of an interesting overview of the efficacy of this approach. So I won't walk through the whole thing, but let me tell you a little story. We take an application and we put it in to the model, and then we see what the model spits out. And then we go back to the actual reviewer assessments for this application, and we say, okay, what did the reviewers catch? What did the reviewers have to say were potential weaknesses with this application that our model did not identify? And then we generalize those as propositions. So if a reviewer said like, okay, in this application, you have spelled out everything you're going to do in phase 1 of your project, and then you've spelled out everything you're going to do in phase 2 of your project, but in phase 2, you haven't in any way anticipated what would happen or what you would do or how you would pivot if you had null results in phase 1. So we can extrapolate that to then another benchmark, such as any multi-phase, multi-step project needs to anticipate, failure or null results in earlier stages as a benchmark, as a check, as an example. So we take that, we feed it in the model, we run another one, and then we do the same thing. We say, well, what did the AI model miss in terms of identifying potential weaknesses? Go back to those review documents. And so this is our kind of scoring over time, as we've just done this over and over and over again. There are many things wrong with this chart, such as if this goes back to a project that started in late 2023. And so, I mean, if we were to rerun this with newer models now, this would all be very different. So some of its improvement not only is us doing a increasingly better job of incorporating new review assessment benchmarks, but it's also to do with the model's efficacy in the output and the identification of those things. But it does give us enough of a sense in terms of a trend line that this is a fruitful and productive exercise. Acknowledging simultaneously the issue is that the higher this number goes up, typically the more output that you're getting out of the model. So what this is not addressing is that you're also increasing your false positives. So we can't assume to know what real human reviewers reviewing a real application will actually say, but we can give an applicant a whole bunch of ideas about what they potentially might say. And that kind of goes back to the question earlier, is if you were if you were an applicant, hey, would it be helpful to you just to have that kind of analysis? We can tell you everything we can possibly think of, how this might be, how weaknesses might be identified in this application based upon past applications, and hopefully, in looking at that, that sparks something for you as an applicant that you might want to change or adjust. Very unlikely that a tool like this would ever get consistently above 80%, because there is at least 20% of things that reviewers say that are either, categorically factually wrong, like I'm not sure you read the application. There are some things that reviewers say that are not entirely like appropriate, like not necessarily following the guidelines of the competition, or being like more specific and like, oh, you should talk to my friend Joe at such and such a university about this question, like things that like they're not really technically supposed to say, and then things that we just can't figure out what they're saying. So it's like if someone was writing their review in the middle of the night on an airplane, like they will write sentences that you're like, I'm not entirely sure. I've got the application, I've got your sentence, and I'm not entirely sure what this means. So that happens too sometimes. So I think there's a solid like kind of 20% of things that you really can't anticipate, as well as things that might just be so specifically granular to the specific research topic and the specific application that you just couldn't generalize in any other way. So that's automated grant feedback. And this next project is Research Mesh, which is very much at the other end of the research lifecycle. So if automated grant feedback is like really trying to support in the pre-competition, pre-award space, Research Mesh comes kind of at the end. And the question we were driving at here is like, how can we systematically support knowledge sharing for every new research article that is published? And that, for many reasons, didn't seem like a conceivable thing we could even ask before the explosion of AI, but it's a question that now seems worth exploring. And so here our strategy was to develop an end-to-end automation that does everything, identifies new research articles, and then manages the entire pipeline of communication around those for some specific groups of knowledge users. So this is what this tool looks like. Also a pretty straightforward, simple web form. There are some details that a user would fill out, obviously, and kind of your login and administrative details, but then the research unit that you're creating this for, the institution where that research unit is based, a number of settings, which I'll talk about in a second, the address of the institution, the colors, the branding colors of the institution, the ORCID IDs of the individuals that for whose research you are seeking to share. And then the tool goes off and does a bunch of things that are very, at the beginning, just very linear and mechanistic. So it goes off and identifies what are the new publications for this specific cluster of researchers. And I mentioned it uses ORCID IDs as the kind of as the ground source of truth in terms of the ORCID being kind of the gold standard for author disambiguation in the scientific literature. Then it, based upon, okay, here are these researchers. What have these researchers published recently? It then compiles and structures that publication metadata from the various scientific knowledge graphs, all the different places where metadata about publications ends up being stored and housed. And we really then want to build this around kind of like open science principles of making research more discoverable and accessible. So the entire workflow here, we haven't gotten really much to the AI part here, but the whole kind of earlier workflow is really based on how do we access open and publicly available metadata. So this is all the boring grunt work of determining the data. then once we do that, then we can get into the AI, the fun AI things of leveraging AI to create some digital media assets to enrich communication. So we do a lot of context engineering in this workflow to ensure that we have the right data for the right article before we get to the point of asking an AI to do something with that data. And then throughout the whole thing, there's a human in the loop, multiple humans in the loop. So it's automated, but there's people who can watch it. It does all of this, and then it creates a weekly or a monthly newsletter about new research publications. So kind of an on-demand digital magazine wrapper. And we like to call this kind of a plug and play mini virtual comms team that can be used kind of at scale for any research department or network. So my slides are not advancing. Hold on, let me see. Oh, now they're advancing, all advancing. So this is kind of cool in the sense that our only inputs are, from the user perspective, the only inputs are, here are the ORCID IDs, here are the people, and then everything else you see on the left-hand side of the screen is generated with AI. So the user has set the affiliation piece here, who is the research unit we're tracking here, and they've named the newsletter. But this image is AI, obviously. This summary here is AI, which is a quick overview of the items that are going to be explored in this issue. The reader can listen to a podcast overview of what is to follow as well, so as well as access the transcript text. And then each new article that is being explored in this issue is headed up with a kind of curiosity gap question prompted by the research question of the article. And then each article is shared with kind of that question again, which is the anchor back from that table of contents. But there's this kind of light iconographic image and a quick overview of what exactly the researchers did in this situation. If you click on just about anything here, it takes you to the DOI, the article itself, unless you click on summary here. And if you click on summary, then it pulls out to a secondary page that it creates separately, which does a more of a plain language summary of the article. Really based on the abstract, but preempted by like what would somebody need to know and who's not an expert in this field to understand the substance and the findings of the article. And the email then concludes with all the things that you would typically find at the bottom of an email, and things, unsubscribe options, addresses, and whatnot that you need to be compliant with the various international rules and regulations around email communications. So just about everything else that's not AI can be like mechanistically configured. The newsletter name, who exactly the researchers are being tracked, how often the newsletter is sent, when the newsletter is sent, the citation format, the colors, the logo, the maximum articles included. You can have an inclusion criteria if you wanted to, say, throttle the topic around a specific issue, and some specification around target audience. So we're excited about this because it's super, super scalable. So we have kind of beta testing deployments across a lot of different departments. So if you think about the typical university structure, you've got your top level administration, and then you have faculties, and then within those faculties, you have departments. I've spent a lot of time in my life both working at the department and at the faculty level, and because the ongoing challenge, the ongoing resource challenge is like there's not a lot of communication support that often really trickles down to very specific research that happens at the department level and down if it was a hierarchy. Um, and so with this tool, we're able to say to a faculty, every single department in this faculty can have their own newsletter, can have their own archive of their research, and we can do this at scale. So being able to help focus the topic of the newsletter much more around departments really helps departments engage in very specific audiences that would be, more interested in the research that they do. Also gives departments the ability to really define the scope of, like, when you say research in this department, who do you mean? So for a department, that could be like, well, let's also include all of our trainees and graduate students and our research associates instead of just our faculty members, or another department might not want to do that. And it's just nice to not have to be able to make that choice universally for everyone, but be able for individual units to do what makes most sense to them given the audience that they are trying to reach. The tool also supports custom content, so admin can add information about events or webinars, recognitions, milestones. Nobody likes making newsletters, as far as I can tell. So to be able to have as much of a newsletter that's automatically generated, that just happens in the background is great. But then to also have that in a platform where people can, when they need to, add specific things to it. And then another cool use case we're seeing is like the institutional network option. So the tool is agnostic about who that collection of ORCID IDs is. So you could also use this with a interinstitutional like network working on some issue. And then, those could all be included in the newsletter. And then you could use that inclusion criteria for being very specific about the publications that would be featured in the newsletter. The admin on the back end, as one of the humans in the loop, eyes on the process, receives this report that comes to them a couple days before a newsletter is scheduled and provides them with an overview of all of the content that would be generated for that issue. So they can see, you can see here, these are just the items that we saw in the last example, but it also gives them this sense of, here are the articles that are still under article monitoring here. Here are the articles where we're still trying to collect metadata. Here are the articles that we are ready to go, but we're at our minimum or maximum set for this issue. And this project, just because it's so focused on like open, accessible communication, open science, this has been a project we've been able to collaborate also just interinstitutionally on. So there's about 35 pilots in various stages of beta testing across a range of institutions here. And we're open for more. So we have just opened another round of bringing on another round of internal beta testers. So if you work with a group of researchers, whatever that means, so it could be a department, it could be a center, it could be a lab, it could be a network, it could be any such conglomeration or triangulation of research individuals, and you're interested in just beta testing to try it out, please shoot me an email when this is done, and I'd be happy to chat more about that. And the only ask from our side is like, let us know when it doesn't work and what's broken, because it is still in active development and we still do occasionally break things. So with that, checking time, a few reflections and I guess provocations. So hopefully we have lots of questions and lots of things to think about. I've been thinking a lot about like what are the labor implications at the surface level of all this. Like AI has created so far the opportunity to do a bunch of things we couldn't do before, and I feel like it's created more work for me than less. In one sense. But I don't want that to be the only sense or the only way that I think about it. So I've been trying to think also very, very critically about the work as we go. There's an article which you can look up. I can share the link with Anna as well. We could include it in the material afterwards. But there was an article by Peter Reinhardt in 2015, and he identifies this idea of being above and below the API. Now, this article is written at the time, I think Uber was 5 or 6 years old at the time and kind of just, taking off. And Reinhardt's observation is you have the company, you have all the engineers at Uber who design the system, and then you have the drivers. So you have people who, agree to be uh, the operators, essentially, who, have the Uber app on their phone and it tells them where to go, it tells them who to pick up, it tells the driver where to take them. And Peter's observation was like what you have in this kind of emerging work environment is the people who work above the API level, who manipulate the API, who are in control of that data and how it flows. And then you have the people who are below it, who are dependent on it, and they can't do their job without it, but they have fairly little agency. So, the level of an agency of an Uber driver in this case is I choose to be an Uber driver. But once I've chosen to be an Uber driver, very little agency about what I'm doing in my day to day. So that was that's an interesting observation about being above or below the API as a way, not the only way, but as a way to think about work structure. And I think what nobody saw, I certainly didn't see in 2015, was the potential for administrative knowledge work also sinking below the API. I mean that like if if our work is dependent on using a chatbot, and dependent being the key word there, like if we cannot do our job without the chatbot, then in a very real sense, like our work is happening below the API. So we do have some autonomy in the sense that, like the Uber driver, we choose this path or we didn't, conceivably. But, Reinhardt's observation, which I just keep thinking about, is that work below the API is probably like the first things that will be automated. Theoretically, it would be theoretically, if a machine can get the operating instructions to the level of an API that a human then does, then there's the most incentive for whatever corporation is running the API to keep pushing that automation further down. There are interesting kind of hypothetical scenarios then about how this all plays out. And so a couple of the scenarios that I've been thinking about are, it could be that AI turns out to be like shipping containers, which is to say shipping containers were a very interesting innovation, created all kinds of efficiencies in terms of the way materials move around the world. It opens up all kinds of interesting new commercial corridors, eliminates massive inefficiencies because in terms of moving stuff, it's the same container that goes on the ship, off the ship, on the train, off the train, on the truck, off the truck. So massive new efficiency, massive new technological efficiency. But with shipping containers, there weren't really many people who just like became madly rich. Like the wealth created by shipping containers pretty much went to all of us, in the sense that it got cheaper to move things because it was more efficient to move things, and that's good for all of us because now things are cheaper to move, as opposed to a bunch of wealth. The people who invented the shipping containers, yes, some of them got rich, but nothing like they not become tycoons because of it. So that is one real possibility, that the current trajectory of how AI is being built out and constructed and rolled out is not scalable in the long run, and that many of the current players end up going bust or end up consolidating, and it's potentially in the long run there's actually less wealth ultimately centralized because of this tool than it looks right now. It could be one possibility. The other possibility would be like it does usher in kind of new oligarchic empires. Um, uh, and I think this kind of comes back to like why the gold rush right now on AI? Like why this kind of investment? It's because like if you become the AI, you could become the API to rule all APIs. Like you become like God API, and then the economy is now you know uh, dependent on you. So if you're interested in exploring like the potential critical angles of this, I think these are both really fantastic books, Power and Progress and Empire of AI. Um, both both fairly recent, both very timely. Power and Progress is a big one. It is an excellent analysis of the last 1,000 years of technological progress and who has been the winner and the loser of technological progress along the way, and what were the ramifications or the contextual conditions which made workers either the beneficiaries or the victims of progress. So it's a great historical analysis and very much kind of tries to then situate like the AI moment in a broader historical context. And Empire of AI is very up-to-date analysis of how exactly the companies that are accruing the billions in capital, in venture capital right now, how they came to be. So both really good. Yeah, so that big kind of question is like, when does technology serve the workers? And I think the interesting takeaway from the historical analysis is that it sometimes does and it sometimes doesn't. But whether it does or whether it doesn't has more to do with the environment and the conditions and how well labor is organized as it does about the technology itself. And so I think it does like strike me like also important, like how valuable networks such as this are, because it's not, I don't think the idea should just be how do we deploy AI because we need to deploy AI, but also, as we learn from one another as we go, um, how do we have like open communication? How do we, as people who are employed, who are working, who are workers, using a new technology, we are in a not unusual situation. If you look at the past 1,000 years, this has come many times before, and it seems that it's always good that there's more communication happening among workers than less. Put it there for now. So if a new technology emerged with the apparent potential to centralize power and increase social inequality, and I say potential because I don't know, it just seems like it could, and it might, but it doesn't, won't necessarily happen. But if it had the potential to, how should you use it? And that's where I think those kind of questions about learning from past waves of technology are really helpful and important. So in closing, I think I'm going to leave time for some questions. So I'll just a couple of last thoughts here. I think it's worth thinking about in terms of deploying AI, where we're doing it. So I think because we got sold chatbots as the face of AI from the outset, and there's historical reasons why that occurred. But we got sold chatbots as the face of AI, which is this promise about individual efficiency. And so we will become better employees, we will become more productive employees, we will become better cogs in the machine if we can deploy AI correctly, we are told. But I think it is worth thinking about in terms of like the value we bring to our institutions and therefore the security that we bring to our work. Also thinking about these questions in terms of institutional efficiency. So thinking about processes where it's great to think about personal productivity, but it's also really good to think about like, well, I can do this thing more efficiently and effectively. But if there's downstream processes that just stymie the whole thing, then there's systemic questions to ask about priorities. So I think there's good room to think about prioritizing the API and not the chatbot as the tool. And the good news is that you don't need to necessarily be a computer programmer or a coder to be able to do that, be able to do this, but it does mean learning some new tools. So that might be Power Automate or Zapier or Make. And basically with these tools, I think our upskilling priorities are learning more about databases, learning how to use loops, and then learning how to use APIs. So that is simply to say, if you have a database of a bunch of information, you can have a loop that says, well, for each row of this information, I need to do something with this data. And you can use an API then to do something with that data that can then turn into other materials or be converted to other databases. But with in terms of like trying to boil it down to like what is the simplest articulation of how we could kind of rethink our roles in enterprise institutional contexts. These are really the three things I think are really worth exploring. And like I said, the ask is not necessarily become a coder, but I think we need to think a little bit more systemically about processes. So we could imagine a future hypothesis could be like the future of human knowledge work, the stuff that we do in research administration, not doing the same thing over and over and over again, but thinking about how people who work in knowledge work add value by improving processes. I'm just going to, a couple quick, one couple minutes. In terms of thinking about what to look for, I think it's really great to think about anytime you're copying and pasting something, a little red light should go off in your mind and think robots are really good at copying and pasting something. Even without AI, robots are really good at copying and pasting things. So any things that we're doing that are, rote routine processes where humans are the robot moving the data from one place to another place, we should think about automation there. And then there are things in institutions which I would just call broadly like insufficiently prepared document bottlenecks, which is like human beings are looking at things submitted by other human beings that are not ready to be looked at yet. And there's like kind of opportunities to use things like automated grant feedback or like other like augmented document preparation workflows. I've been working on this as a kind of a kind of taxonomy to think about projects and where kind of current projects and future projects and how they kind of fit. So in that top row, you can think of a wedge project as something that is working between a user and or between systems or databases. So like the automated grant feedback tool I showed kind of does that, right? There are existing processes in terms of funding grant development, and there's everything that happens downstream in terms of submission and all of that. But this is like a wedge in between some of those existing processes to provide grant applicants with more feedback. But you could also have a bridge process where you're really working between two existing systems or databases. An example of that might be like auto-populating an institutional repository with new applications, new journal articles, pardon me, or looking at like, well, what are the opportunities for like the grants, finance, HR integrations, which are generally typically notorious, really terrible. But you can think then about judges, like steps between processes, hedges, working alongside other processes. So like risk mitigation, monitoring, compliance insurance, risk assessment, all sorts of opportunities there. So you're not necessarily adding something new into the workflow or into the system, but you're adding something alongside of it to do more of that assessment work. There's also called Ledge. I wanted everything to rhyme. So Ledge, like synthesizing data, the Research Match project is kind of doing that, right? All that data is already there, but it's using automation to corral it and then do something to corral it so it's structured to then be able to do something productive with it. And then all these options, all these intervention points, I guess, like do come with their own kind of unique challenges. And this was not meant to be a table of all tables to rule them all, but it's just been a way that I've been thinking about conceptualizing where projects could fit as we conceive of them and as we implement them. So uh, last thing I'll say is that these are as much people projects as they are AI projects. At the end of the day, all of these things depend on people working together and sometimes working together in different ways or ways that haven't worked before. And that is always a human thing.